Understand how version control is done at a very high level, and we look at how Git tools like Git or Bitbucket are helpful in real world. Okay, great. Let us look at a use case in terms of let's take a company like Zoho. Okay, Zoho is a company which produces products uh, like expense management, manage your bills, generate invoice. Okay, maintaining your balance sheets, your inventory, the products you create, and your financial management, like budgeting, spending, expenditure, savings, all those stuff. This is like a in-house suite for variety of organizations. Like for example, if you take a brand like mm, Raghu shipping industry. Okay. So Raghu shipping industry will typically assume it does imports and exports. They use Zoho to manage their expenses, generate invoices, submit balance sheets to government, manage inventory in their warehouse, and take care of their balance sheets, budgets, savings, expenditure, saving, etc. Okay. So a company like Zoho, when it is offering multiple products like a suit to company like Raghu Shipping and Co. or any other company, behind the scenes, the company will eventually have different dev teams for each product. So for example, expense management, you have one dev team. You have another dev team for invoice. You have another dev team for balance sheet module. You have another dev team for inventory. So each of these dev teams write their own code separately. Okay. But when they publish a suit, they are required to merge that code so that it can be used by Raghu Shipping and Co. Okay. Now, when it has different dev teams, you have too many people part of each these teams. Different people will touch different parts of the web page. It can be a web, it can be a backend, it can be middleware, it can be API. So when there are so many files coming into picture for different dev teams into multiple products into single suite, it becomes difficult if a strategy of managing version control do not exist in practice. Okay, that's why maintaining your code branches across dev teams, merging them together in particular form so that it becomes a single product, plays a key role in delivering the product to customers like Raghu Shipping and Co. Now, how do they achieve it? They achieve it using what we call version control. And this version control is typically taken care by two teams, dev operations and release management team. Okay. We'll see how this works with a very simple example. Okay. Imagine there are three students in this MTech course. Okay. Three of them are working on one project. Let's assume that project is about attendance management system. Okay. Student 1 is writing the web page where he will give the ability to choose attendance so that students can do present and absent, etc. Student number 2 is writing the middleware where whatever input is given by the web, that input gets stored in the middleware. And student 3 is writing the backend, which is the database. So he takes care of all the tables, etc. So when student 1 prepares a web, he defines certain properties in the web so that they are read as an input to the middleware. That middleware you will eventually have to store data in the respective tables. Okay. So if student 1 is writing code today for his web page and student 2 writes it tomorrow for his middleware, if he doesn't pick the correct version of the page written by student 1, then his middleware may not be holding the right values. So let's assume student 1 has given version 1 page to student 2. But he realized that I need to do certain change and then he created version 2. But if he forgot to share this version 2, then his middleware is incorrect, right? It may not store right data or not manage right data. So today, student 1 and student 2 are interacting by sharing version 2, version 3 files just by emails, okay? Or through file share, or he might be just sharing in pendrive. Because of that, student 2 is getting frustrated because every minute student 1 is giving a new version. I'm not able to finish my middleware properly. Because of that, when student 3 is trying to define tables in database, because there is uncertainty in the source and there are too many versions coming from the source platform, student 3 couldn't even start the table creation because student 1 and student 2 are unclear about which version of the file they need to pick. This is the classic problem where when multiple people are involved in building one product like attendance management system had to face, because if they don't use right version, the underlying teams who work or depend on those files may not deliver on time. Okay. So to solve this problem, what people do is they use simple methods like version control. Okay. Let us see how that version control works. So imagine there is dev team 1 who is working on web. There is dev team 2 who is working on middleware. Dev team 3 who is working on database. All the code they write sit in one place. That place is called main repository. Let's give a name, main repository. When the developers from the web team build something, they push all their files like .html, .js, .css, all these files bundled together and they push into this main repository. When this dev 2 wants to write middleware, he will read that files from the main repository and start applying the middleware logic. For example, if he ends up writing some logic in JS or some JSP or some API file, okay, he will bundle it and he will push it to the repo. The DB guy will read the latest repo from this main repo and write tables. So he will write a schema file, he'll write a data file, he'll write a constraint file. And then all this data, he will push it to the main repo. So if you carefully observe, dev 1 is completing their work and pushing their files into main repo. After that activity, the dev 2 are actually picking the file from the dev 1's output. So basically, one second, let me take this color. So basically, the output of dev 1 is becoming the input of dev 2. The output of dev 2 is becoming the input of dev 3. This is a waterfall approach. Okay. So in waterfall approach, one team completes the work, the other team starts the work. This team completes the work, the other team starts the work. The primary disadvantage of this model is you have to keep the downstream teams waiting until the teams on the top complete the work. That is the primary disadvantage. So you are wasting people's time and effort, so that the output needs to be moved to the main repository, and then it becomes an input to the other repository. So to solve the so people started using waterfall to address the gap which you have seen with the attendance management. Okay. But what they have done when they started using waterfall, they realized that the disadvantages aspect of this approach is lot of time based and effort, and I'm slogging my underlying teams for more time. So to avoid this problem, what they have done, they have come up with a better approach, which is a approach which is used by most of the companies. Okay, let us see how this looks like. So, for example, dev team one who is working on backend, dev team two who is working on middleware. This is web. This is middleware. This is backend. All of them will start their work simultaneously and keep their files in what we call local repository. Okay, they keep their files in what we call local repository. Okay, so when they keep this in the local repository, this is nothing but the files which are confirmed as output of the particular team. Okay, so when they push these files before to the local repository, they have something called working directory. Okay, they have something called working directory. So every dev team will have their own working directory. Working directory is the place where you have your local code. So you write a HTML file, CSS, JS, or files related to any web framework, you keep in one fixed folder. That is called working directory. If you're writing a middleware, if you're defining APIs, all your endpoints, all those details, you keep it in your local working directory. That is a fixed path. If you're from a DB team, if you're defining tables, if you're defining schema, if you are populating with dummy data, you keep them available in your working directory. From that working directory, you push those files into the local repo. This local repo is what we call a shared local repo. Okay. So the work done by the web, the work done by the middleware, the work done by DB are pushed into the shared local repo. If someone wants any changes to be done, they will go back to the local repo, read the files of the other team, and again publish the latest version. Okay. So when they perform these activities, they will get to see what are the differences from version 1 and version 2. Now the developer from the DB team can decide which version he need to pick, which change he need to consider while pulling the file from the local repo. So imagine at 10 a.m. the web team is pushing file 1 to local repo. 11 a.m. the same web team is pushing the file to the local repo. At 12 noon, when DB team wants to read this file 1, they will have a choice which one to read. Do I need to read on file 1? Do I need to read on latest, which is file 2? Is something they can decide. Now, which file to read, it depends on the design. But the point is, if you look at the past problem, because it is waterfall, they have to wait for all the files to be finalized by the web team and the middleware team so that the DB team can work on. But here that is not the case. You now have an ability to read the file whenever you want based on the version which is pushed by the respective team. Once all the files are gathered together and they assume that the development is done, the files from the local repo, we shall change the color. Now, the files from the local repo are pushed into a remote repository. This remote repository is the final code which is used to deploy to Raghu Shipping and Co. so that they can use it in the end. Okay. So if you carefully observe, teams are no longer working in waterfall. They are actually working in distributed in a distributed way, so that they push their versions into a local location and reuse the version which they want, and then and then publish the final version so that it goes to the respective repository. Okay. So in a large product where you have different teams working on expense, invoice, balance sheeting, inventory, financial management, like in a product like Zoho, each team has their shared repo. When they want to publish the final suite, they will merge that entire repo into one remote repository and then create a installable suite. Okay. So this way, the versions of a source code are managed. Okay. Now, all these things are at a developer level, at a team level. Okay. But if you want to look at an individual level, if you are a new hire joining any IT company and you were given a task to change the background color of one HTML file, how version control will be applied to you? Okay, that's something which you need to focus on. So, you are in this use case of changing the background color, you are not creating a new page. Okay, you are reusing the page which is already available in the production. Okay. So what you will do, you will take the file which is already in the remote repo, because remote repo is the place where you have your final files. So you read this remote repo by using a version control command called pull. Okay. You pull that file. So among 1,000 files, there could be one HTML file which you want, where you want to change the background color. So you use a command called pull to read that file from the remote repo into which place your working directory, which is your local folder. Okay. From your working directory, you make the changes. Like for example, you do BG color, you added a CSS and you made BG color yellow. Let's assume that is the change you have done. And this is your new HTML file, V2. This is the first file, V1. Now, when you finish your development, you don't push directly into the remote repo because it requires testing, right? Someone has to check whether you have done it correctly or not. And they have to review your code, whether your code is correct or not. So that is where a sub step is required. That is called staging area. Okay. Staging area is nothing but another intermediate machine where you send your files, the changed files only, into this space. Okay. In this space, you will be reviewed by your senior developer who conducts a code review. Okay. Code review is an activity which a senior developer does it to the junior developer to see whether the code he has written is correct or not. Okay. They typically judge, they check whether he's following all best practices or not. Is the syntax correct? Will it give right results? All those things are reviewed using at a code review stage. Once the senior developer signs off, this code is used by some QA resource to do testing. Okay, they will test whether the color, whether the ask is to change the background color to yellow, right? Whether the ask which was given to the underlying developer was addressed or not. Okay, that activity will be done by the QA resource. Once the QA resource tests this code and signs off, the junior developer will move this code to another place called local repo. Okay, local repo. Local repo is a place specific for other developers in your team who are also doing changes on the same file or some other file. Even for them, imagine there is another developer, developer 2, has done some change in JavaScript. Let's assume he disabled the right click in the web page. Okay, he wrote a function where he disabled a right click in the web page. Now that JavaScript file will also go to the staging area. Again, a senior developer will review the code and the QA resource will do the test. And the changes of the senior developer and the junior developer are what we call added into the local repo. Okay. Now the movement from the working directory to the staging directory is called file add. The movement from staging area to the local repo is called commit. Okay. So you pull the files from the remote repo. Even the even the other developer is using JavaScript change, pull the file from the remote repo, and then works on working directory, makes the change, adds into staging area, gives it to senior developer for code review, gives it to QA for testing. Once it is done, it is committed to local repo. Okay. Once the local repo has exhaustive number of changes, okay, this local repo will have a push. This is a push command, where a push command will update the remote repo. Okay, this cycle, pull, add, commit, and push, typically is done once in a day. Okay, imagine all the developers start their development at 9 a.m. When they start, all of them will do pulls. Then they do the changes. Then the staging area they add. Code reviews happen. Testing will happen, and they commit to local repo. In the end of the day, like 9 p.m. Okay, in the end of the day, there will be a job which will merge or which will push all the files into the remote repo, so that for the next day your remote repo is updated with all the changes. Okay, so typically in similar cycle, a large company like Zoho, like the way they maintain local repos, every night or every week, in some cases twice a week. In small companies, the changes are once in a month. In large companies, large teams, it will be on daily basis. So at one night, all the changes which are present are merged, are pushed into the remote repository. So that your remote repository is updated. Okay. So this is how a typical versioning is done. You typically pull, you add, you commit, and then you push. Okay. Now, how do you do these activities? Okay. There are tools. So the commands like add, sorry, should start with push, sorry, pull, add, commit, okay, then push. All these actions are typically used by can be possible by version controlling tools like Git, Bitbucket, Gerrit. These are all version control code repository tools, okay, which provide you these commands. These are generic commands. These tools will have respective their own commands, okay. For example, if you are using Git, the command will be typically git add. If you are trying to commit, if you are trying to move a file from staging area to local repo, it would be git commit your repository path. If you want to add, git add your repository path. So the point is the commands stay the same, but the way you write the command will change in Git, Bitbucket, Gerrit based on the syntax, okay? Which is not complex, which is pretty simple. But the important point is you need to understand how these commands are responsible for certain tasks, okay? So the pull will pull the data from remote repo to working directory. From working directory, the changes you make will go to staging area. And from staging area, you go to local repo through commit. And then from local repo to push, which is your remote repo. Okay. Any questions so far? Any questions so far? Okay, go. Now let us look at one example. Okay. I'll give you one example. Okay. So imagine you joined a company where you are responsible for updating a JavaScript where you have to add a date in a particular part of a page. Okay. This is you. There is another developer who is responsible for changing the background color of the same page. Okay. But he's using JavaScript to update the background color based on the time of the day. So this developer too require your change. Okay. He's dependent on your date so that based on the date time, the background color will change. That's the change he's writing in his JavaScript. Now take developer 3. This guy is also playing with JavaScript where he's trying to disable the right click. Okay, let's assume he's doing disable the right click. In the morning 9 a.m., assume all of these developers will do a pull from remote repo. Pull request 1, pull request 2, pull request 3. Okay, 3 of them are doing same pull request. Now they made changes. Okay, let me use different color for understanding. This is not visible. Huh. Now they made changes. Developer 1 pushed it to staging area. Developer 2 pushed it to staging area. Developer 3 moved it to staging area. Okay. Now the code review happens. So someone does code review and someone does QA. Both are pass. Code review, QA, both are pass. Code review, QA, both are pass. Now what they'll do, they will have to merge it to a local repo, right? So in this local repo, the page where it has the JavaScript, it has 3 changes. Change 1, date coming from developer 1. Change 2, background color based on the date timestamp coming from developer 2. And disable right click, which is coming from developer 3. So these three changes typically sit in local repository. Okay. Now the big question is, who takes care of the activity? So this is um, add. Okay, this is git add. I just write it before I forget. This is git add, and this is git commit. Okay. So these are the commits. So when people do the commit, the tool like a Git and tools like Gerrit and the tools like Bitbucket will show the dependencies of the same file. Hey, there is a write on file 1 from this commit ID 2769. There is another commit from a commit ID 1673. There's another commit from another ID, commit 37, etc. etc. The DevOps engineer will have to write bash scripts, okay, to check if these interdependencies break the file or will keep the file intact. Okay, how do they do that? I will show you in a small demo. But typically that's how the DevOps resource comes into picture. They take care of these multiple commits merge into local repo, and then you have a common file sitting in local repo. Once you have a common file in the end, in the night, all these files will go and get into remote repo by using push. So again, the dev operations resource will write one job. Okay, he'll write a batch job to read all the files, merge them together and push into the main repo using bash. So this is where a typical individual developer based changes are tagged by version control. Okay, got it? So this is how an individuals work. There is another example. Okay, let's look at from another dimension. Okay, let's look at from other dimension. Okay, imagine this is your working directory. This is your staging area. This is your local repository. This is your remote repository. Okay. Imagine all developers are here. Daily, these developers pull the files from remote repo through pull. Okay. Then what they do, they make changes and they push those files to staging area using add command. And once the QA is done, code review done, they move that to local repo using what we call commit. Okay. And then from there, once the commit is done, all the files which are bundled by all these people at that day will be pushed as push. Okay. Now this is what I call an ideal condition. Ideal condition is there are no issues. This is ideal condition. If there are any QA issues, if there are any code review issues, okay, what happens? You will have to again redo the work. Imagine you have not done background color change correctly. You have missed some tag. The code reviewer said, hey, do the change, do the correction, okay, and come back. Now, the question that this developer who is working on this background check is, do I need to use the same file which is coming from remote repository, or do I need to use something from local repo? Because what could have happened, sorry, where is the pen? Yeah. So for example, I'll repeat again. I think I missed it because there is a screen issue. So my point is, apart from this ideal condition, if the coding and QA goes wrong, the developer has to redo the work. when he redo the works, he has something in his working directory, right? Which he can do the change. But the question is, by the time he does the change, there is another developer who might have already pushed the same file to local repo, right? Because his QA and his code review might have been passed. So the duty of the developer too, who got his code review and the QA failed, is to go back and check if there is any updated file in the local repository that given day. So all the developers, when they are pulling files at 9 a.m. from a remote repository, there could be some people who might have finished their work and pushed the files into local repository by 10 a.m., which you don't know, right? But your code review and testing completed at 11 a.m. Now, instead working on something which you pulled in the morning at 9 a.m. from remote repository, it is your duty to check if there are anything already committed to local repository. Okay. If they are already committed to local repository, what you have to do is you have to merge your working directory pulled files. Okay. You have to merge your working directory pulled files with the files the other developer who committed into the local repository. Okay, using the command called merge. So the merge is used to check the commits performed by the QA and code review signed off changes. If your code review and QA are not signed off, then you will eventually have to redo the work. Okay. Once you do the merge, you will get the changes of this developer also into your working directory. Now you do the change, you again git add, you get your QA and your code review done, and it goes to commit. And then you eventually push it to the remote repository. Okay. This is a typical change which happens in a given day. Okay, in a given day, if multiple people are working on same files, this is what the merge is, something which you need to look for. If there are no commits on the same files which you have done on that day, you can work on your working directory files and just do the add commit again. Okay, but there is a higher possibility that because you are sitting in a large team, different people will work on same pages and they push the files into local repo. Okay, so that that night all the files from local repo will be pushed into remote repository, right? So that is why it is your duty to check if there are any updates. Then you use what we call merge, do the changes in your working directory, git add, git commit, and then move to local repository. Okay, so these are something which you need to practice. Considering the time, because you have to leave by 9:10, just give me 2 more minutes. I'll try to explain you what we call fetch and what we call checkout.
Hello, sir.
Yeah.
Sir, we have to leave at 9:10 only on Tuesday.
Okay. Okay, then what I'll do, I'll cover the rest in the next class. Okay.
Okay, sir.
Okay. So in the next class, I will cover git fetch, checkout, and there is something called clone. Okay. These three actions. The key difference is all these actions are common across all tools like Git, Bitbucket. Okay. Only the syntax will change. I'll show you one example with Git so that you can practice. I'll give you a self practice, do it yourself kind of a note so that you can practice by yourself. Okay, but this is what I want to cover for today's class. If there are any questions, feel free to write to me or you can reach me through email. Okay, great. Thank you, team. Have a great day.
Thank you, sir. Sir,
Yeah.
can I ask you related to assignment?
Yeah, tell me.
Sir, in question 3, you have given that stoplight game.
Hmm.
So that we have to implement using bash script,
Yeah,
right?
yeah, yes, yes.
Because it is not mentioned, that's why I was having doubt.
Ah, it's using bash. Sorry, it's using bash.
Okay. And sir, in Git, you have mentioned that we have to make a branch
Hmm.
and then we have to pull.
Yes.
So, sir, that code we already having in local, so why need to pull? I mean,
I'll explain that. I mean, so the assignment is like you can write all your observations based on what you know, so that you
okay,
know we will eventually evaluate that way. So if you
okay,
relieve the answer, then it would be public to everybody, right? So that's the point of that question. So if you are trying to do it, there is a possibility, there's no possibility. You can answer what you know. You can come back with that answer. You
okay,
got the
sir.
point, Ashish?
Yes,
Huh. See, so to arrive at an answer, you should know, right? What is branch? Then how do you pull? Then if it's possibilities, if no, there impossibilities, then you can tell the impossibilities and answer it accordingly. Okay?
yes, sir.
Yeah, it's like a trick, and I think everybody got to know about it. Okay, cool. Any other questions?
No, sir.
Okay, thank you. In tomorrow's session, we'll cover other commands. I'll show you rough kit and then we will go to camps. Okay. Thank you. Have a great day. Bye.
Okay, sir. Thank you.